Hello students, welcome back to Math Java programming tutorials. In this video, I'll discuss three concepts: matrix addition, subtraction, and storing random numbers in a matrix. Let's see the introduction. The elements of two or more matrices can be added or subtracted if and only if the order of the matrices is same. That means equal number of rows and equal number of columns are required. For example, matrix 1 has 3 rows, 3 columns, and matrix 2 also has 3 rows and 3 columns. Then either addition or subtraction is possible. The second example, matrix 1, 2 rows, 3 columns, A by B matrix. A is 2 rows, B is 3 columns. Similarly, matrix 2 also has 2 by 3 matrix C by D. In that case, addition, subtraction possible. Whereas matrix 1 in the third example has 3 rows and 3 columns, whereas matrix 2 has 2 rows, 3 columns. In this case, order is not same, so addition or subtraction is not possible. Now, what is matrix addition? Let's assume there are two matrices X and Y. Elements are already there. In that case, Z matrix will be having the addition of X and Y. That means each element will be added from X and Y and stored in G. How? See, 1 plus 1 is 2. 2 plus 3 is 5. Then 3 plus 3 is 6. So this is matrix addition. Each element will be added x plus y. X of 0, 0, y of 0, 0 will be added, stored in z of 0, 0. Similarly, matrix subtraction. X and y, two matrices. 10 minus 1 is 9. 20 minus 3 is 17, and so on and so forth. For this, we need to access each address, each element's address. The address is rows and columns. We know that 0 row, 0 column, 0, 0 address. Then 0, 1, 0, 2, 1, 0, and so on and so forth. And any 2D array or matrix can be accessed with the help of nested for loop. Here if you see, j is 0, j less than 3, j plus plus. That means 0 to 2 rows, total 3 rows. K0, k less than 3, k plus plus. Horizontally accesses any matrix. So, what we are doing only one line, that is x of jk, that is 0, 0, 0, 1, 0, 2, then 1, 0, 1, 1, 1, 2, and so on. X of jk plus y of jk must be added and stored in z of jk. Just 3 lines program. If we use subtraction sign, that is minus in place of plus, then matrix subtraction. Let's see the problem statement. Initialize or read two matrices with the same order. Add the contents of the matrices. Store in a third matrix and display all three matrices. Let's assume we are initializing. X is 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 rows, and each row has 3 columns. Then X is created, Y created, again similar 1, 2, 3, 4, 5, 6, 7, 8, 9, order is same. So Z matrix is also 3 by 3 matrix. The constructor has initialized and stored zeros in Z matrix. Now storing in third matrix after adding X and Y. For that we know that there is a requirement of nested loop. Inside that 0, 0, when j is 0, k works 3 times. So 0, 0, 0, 1, 0, 2. First row is accessed. And then second row, because j becomes 1. Every time we have one statement, x of jk plus y of jk must be added and then stored in z of jk. Now let's see the same program in Java environment. Matrix addition program. What we need to do is, we'll accept the order of matrices first. For that, we have declared 4 variables, A, B, C, and D. Read the order for both the matrices. Check if the order is same. Then reserve space for 3 matrices X, Y, Z with the specified order. Then read the elements in 2 matrices by calling read method. Add elements and store in the third matrix. Print all 3 matrices. So this is to be done by us. Let's see, read the order part. If you see here, one print statement, enter the number of rows in matrix 1. A is accepted. Then columns in matrix 1, B is accepted. Then rows in matrix 2, C. Columns in matrix 2 in D. We've accepted A, B, C, D. Now we need to check the order. If A not equal to C or B not equal to D, A is rows in matrix 1, C is rows in matrix 2. So if the rows in both the matrices are not same, or B is columns in matrix 1 and D is columns in matrix 2. So if both of them do not match, then matrices with entered orders cannot be added and return. Return means go back to stop the program. Now reserving space for all 3 matrices X, Y, Z. New int AB. We are not using CD. CD we have used for checking only. A and B. A is number of rows, number of columns. Order is same for all of them. So int X double square brackets is equal to new int AB here, Y AB only, Z AB only. After that we need to read the elements in 2 matrices, add the elements and store in third matrix, then print. So let's see read part now. We need to read in 2 matrices. One is X, second one is Y. Instead of rewriting code again and again, we have created a method called read. And this method is being called from static. And if you see, there is no object here. So it must be a static method. And it is receiving 3 parameters. One is X, that is a 2D array, pass by reference. So X address will go get stored in M. And then AB, integers. So we are sending A to P, B to Q. This is pass by value. Lesson 34, I have explained pass by value, pass by reference in detail, and link is given in the description box. Now, enter A multiplied by B elements in matrix 1. That is, if user gives 3 and 2, 3 by 2, 6 elements, 3 rows, 2 columns. Now read X and AB. X is gone to M, and then we are taking in scanner, running 2 for loops. We know that nested loop, and reading in M of ij. M is storing the address of X only. So the contents will go get stored in X matrix. After that, enter A multiplied B elements in matrix 2, calling the same method. We are not rewriting, but sending the address of Y. Y will go get stored in M, similar process. Again will be read. So X and Y are ready at this point of time. Now we need to add the elements and store in the third matrix. Just 3 lines of code. Nested loop. I0, I less than A number of rows. J less than B number of columns. X of ij plus y of ij is stored in z of ij. This is what is actual addition is happening. Now we need to print all 3 matrices. Instead of writing 3 times the same for loop, we will be calling a method. What is the method? Print method. Let's see the print method now. Now the print method is called 3 times. Print X, print Y, print Z. First matrix is displayed, and then the message, and then X, A, B are sent to print method, which is a static method. And X address will go get stored in M, and we know the printing piece of code. 2 loops, 1 print statement, and then println statement. We have seen this so many times, but we are calling print method. X, Y, and Z are the parameters along with A, B, that is rows and columns. Now, if you see the entire program is like this. First, we have taken A, B, C, D, that is row, column for both the matrices. Read all the A, B, C, D. After that, check the order if they are same or not. If they are same, then declare 3 matrices. After that, reading 2 matrices X and Y, both the matrices. Then add the elements and stored in the third matrix. Print all 3 matrices. For that, with the help of read and print. So total 3 methods are there in this particular matrix addition class. Now, out of which one is a public method, rest of the 2 are private methods. Private methods over here. So let's execute this program twice. One to check whether the order is okay or not. Second one is to just add the matrices. Okay, enter number of rows in matrix 1, 2, columns 3. Enter number of rows in matrix 2. Let's give 3, not 2 rows. And then columns 2 only. In that case, matrices with entered orders cannot be added. That's what they are saying, because 2 rows, 3 columns do not match with 3 rows, 2 columns. Let's execute second time, but give proper orders this time. Number of rows, 2 rows, 3 columns. Again, 2 rows, 3 columns. Then enter 6 elements in matrix 1. Either we can enter with enter sign like 1, enter 2, enter 3, 4, 5, 6, or enter 6 elements in matrix 2. I can give 2 rows, so 1, 2, 3, 2 rows, 3 columns. Then 4, 5, 6. Either this way also we can give input. Then first matrix contains 1, 2, 3, 4, 5, 6. Second matrix 1, 2, 3, 4, 5, 6. Third is after addition 1 plus 1 is 2, 2 plus 2 is 4, and so on and so forth. This is what is matrix addition. Had it been we've given a subtraction sign over here, instead of adding, we can just do minus here. Then rest of the program is same for matrix subtraction. Now see, storing random numbers. Declare a 3 by 3 matrix and store random numbers from 0 to 9. Any order. It may not be like 0, 1, 2, 3. Random numbers. And we know already Math.random method generates random numbers. I have explained Math.random in lesson 30 and link is given in the description box. Now let's see the same program in Java environment. Okay, random program. Here I have declared an array. 3 by 3 is the size. Len is equal to a dot length, that is 3. Running a nested loop to access. But before storing random numbers in the matrix, let's see what does Math.random displays. Okay, Control K. Execute the program and see. Here it is generating 9 random numbers because 3 rows, 3 columns, total 9. 3 threes are 9. See, if you see the random numbers, it may start from 0, 147 till 9. Some random numbers here, 7, 0, 2, starting from all these things. But we want 0 to 9. So we multiply it by 10 so that we can take the integer part. Let's see that. We just multiply it by 10. And Control K, see the output once. Here we are getting 1, 2, 1, 9, 8, 0, 7, 3, 3 random numbers. So we want to take the only integer part from here. So explicit conversion. Explicit conversion, lesson 13. I have explained. Link is given in the description box. Now, what is explicit conversion? We want only integer part of this whole thing. So, Control K, we want only integer part. So, execute and see, only getting integer part. Every time random numbers are changing, they are random. So now this 850, whatever the random numbers, integer part, we want to store in the matrix. So for that, what we do is we take a of ij, that is the address we are talking about, equal to whatever we have written here. Control K. Now A of ij is ready, but not being displayed. So let's go ahead and display. Control C, and I am pasting, but this time we will print A of ij with a tab. So remove this and delete this part because already random numbers are stored in A of ij. So we are printing. Over here we know that we need extra system.out.println, and here it must be not println, must be all the values in the same row should be printed in the same line. Okay, Control K, and over here we need to close the for loop, outer for loop. Control K and then close this, execute. So the random numbers are stored in A of ij first of all and then being displayed. If I execute one more time, the same numbers may not come, will not come basically. Now 987 and so on and so forth. This is about random numbers and storing them in a matrix. Let's see a practice exercise now. Read two matrices, subtract the elements of the second matrix from the elements of the first matrix. Very easy program. Now read a 3 by 4 matrix, and if an element is 0, make the entire row and column to 0. And assume user will input only 1 0 in the matrix. Now declare a 2 by 3 matrix, store random numbers, but from 20 to 40. That is multiplied by 100, Math.random, and then check if it is in between 20 to 40, then only print. This is about the practice exercise. Refer Chapter 7 of Essentials of Computer Applications for further understanding and practice exercises. The next video is about matrix multiplication. Thank you.